Next is density of states, DOS. DOS is defined as the number of electronic states per unit volume, per unit energy range, It is denoted by DE. DE is equal to D N over DE, where N is number of electronic states per unit volume, and then D over D is per unit energy range. So okay, it provide information, DOS provide information about specific heat of bulk material and paramagnetic susceptibility and electronic structure of 3D bulk material, 2D nano tubes, 2D material, 1D and 0D materials. Okay, 0D is quantum dot and nanomaterial and quantum materials. Yeah, okay. So we are studying in this article density of state for 3D objects, 3D material or 2D material as a quantum well, and 1D material as a quantum wire, and 0D material is a quantum particle, quantum dot. So first we study about DOS, density of state for 3D bulk material. So let's consider a bulk of dimensions Lx, Ly, Lz. Let's say this is a bulk material and dimensions are Lx, and let's say this is Ly and height is Lz, and electron in this bulk can move freely in all the three directions, So there are 3 degrees of freedom. D of is 3 because electron can move in all the 3 directions. Yeah, okay. And let's consider a sphere of radius k. K is the wave vector. Sphere of volume V and radius k, and let these are the axes in k space. Let's say this is kx, ky and kz axis, and energy of electronic energy related to wave vector kh, E is h cut square k square over 2m, and let these direction is divided into subparts. All the 3 directions divide into subparts. Let this is kx is 2 pi over lx, ky is 2 pi over ly, and kz is 2 pi over lz. Length separation between these 2 subparts is 2 pi over lx, 2 pi over ly, and 2 pi over lz, and a combination of kx, ky, kz represent a mode, a states. Okay, a state, and these are the dimensions of a small parameter dimensions of a cube. Let's say kx, ky and kz. और इसके जो वॉल्यूम होगी that represent a mode. So on dividing total volume to the volume of one mode, we get number of modes. So let's say n1 be the number of modes, total number of modes that is calculated by volume of the sphere, volume of a sphere to the volume of one mode, volume of one mode. Yeah, okay. Volume of sphere is 4/3 pi k cube. K is the radius, and volume of one mode is kx, ky and kz. So okay, kx, ky, kz is 2 pi over lx, 2 pi over ly and 2 pi over lz. After combining these, 2 pi whole cube lx, ly and lz. From here, number of modes n1 is 4 pi k cube over 3 2 pi whole cube lx, ly and lz. Okay, so we get total number of modes, total number of states, and we know that in one state they exist two electrons together, one with spin up and one with spin down. So total number of electronic state is n2. Let's say n2 be the number of electronic states, that is 2 times of n1, because in one mode there are two states of equal energy. Then we get 2n1 8 pi k cube lx, ly, lz over 3 into 2 pi whole cube. So after solving this, n2 is k cube over 3 pi square and lx, ly and lz. So these are the total number of electronic state, and we have to find out number of electronic state per unit volume. So we divide n2 over volume. So number of n be the number of electronic state per unit volume of specimen, that is volume of this bulk material, that is n is n2 by volume is lx, ly and lz. After solving this, we got k cube over 3 pi square. N is number of electronic states, per unit volume, that is n2 over volume of the specimen. Okay, n2 over lx, ly, lz, and after solving this, we get k cube over 3 pi square is the number of electronic state per unit volume. Yeah, okay. So we get n as k cube over 3 pi square, and for density of state dE is dN over dE. From here, dN over dE is 1 over 3 pi square 3 k square, differentiation with respect to E, and dk over dE. Yeah, let's say this is equation first, and from equation E is energy of electron in the form of wave vector is h cut square k square by 2m. From here we get dE over dk, h cut square over 2m and 2k. After solving this, we get h cut square k by m, and from here we get 2me is h cut square k square, and k square is 2me over h cut square, k is 2me h cut square and root of 2me over h cut square. We have to find out dk by de. यहाँ से भी कर सकते हैं, फिर यहाँ पे k की वैल्यू ये रखेंगे, और यहाँ से डायरेक्ट डिफ्रेंशिएट करके भी हम वी कैन सोल्व आउट दिस dk over de, दैट इज 2m over h cut square, और इसका डिफ्रेंशिएशन होगा दैट इज 1/2 e raised to power minus half. Okay, so from equation first यहाँ से de is 3 cancel out, k square over pi square dk over de, and k square is 2me over pi square and h cut square, or that is 2m h cut square into half e raised to power minus half. And solving this is we get 1 over 2 pi square and 2m over h cut square की power 1/2, 3/2 and e half. This is density of states in 3D. This is density of states in 3D. From here we see that density of state in 3D is directly proportional to e raised to power half. Okay, and plot of density of state with energy is a parabolic. From here this is energy and density of state का इस रिलेशन से जो प्लॉट आएगा, ग्राफ आएगा, that is parabola. de is directly proportional e half. As e increase, density of state increase.